In today's tutorial, I'll guide you through the process of crafting custom jumper wires using DuPont connectors. These versatile connectors simplify the task of interconnecting wires between circuit boards and various devices, including popular platforms like Arduino. By the way, the techniques showcased here are integral to my DIY autonomous mobile robot project. Check out the link at the end of this video to find out more about that. Let's kick off with AWG 24 sized silicon wires. Silicon insulation excels in flexibility, crack resistance and durability. Next we have DuPont connectors and housings in this comprehensive set. The housings come in different sizes from single pin to 8-pin housings, accommodating various needs. This set comes with some plastic wire, which looks as though it is about 28 or 30 AWG, which is fairly small. I will set this wire aside today. A large number of female connectors are included, and also a corresponding large number of male connectors. There are also rows of header pins. You can customize your connections by snapping off the desired number of header pins for soldering, as demonstrated on this perf board. You'll also need wire strippers. These ones are very inexpensive, but only go up to 22 AWG. However, I found that even the cutter die for 20 AWG would cut off some of the copper wire together with insulation, so I ended up using the 18 AWG cutter die on these wire strippers. And we'll also need a crimping tool, which is the most important tool we'll be using in this video. I'm using a Hosan P706, which is a Japanese brand. We're going to make a jumper wire like this one with a 2-pin female connector at one end, into which a blue wire and a green wire are connected, and separate male connectors at each other end. I opted to trim the wire to a length of 150 millimeters. I carefully extended the wire along a ruler, pinched the designated end with my fingers at 150 millimeters, and then snipped that end with wire cutters. When preparing your wire for a connector, start by stripping one end to an optimal length, typically between 2.5 and 5 millimeters. If you find that you are also removing strands of wire together with the insulation when you're using your wire stripper tool, consider using a larger size. For example, for AWG 24, I chose an AWG 18 cutter die on the wire stripper to ensure a precise insulation removal without damaging the wire at all. Gently twisting the bare wire could be a good idea just to maintain its integrity. As you can see, I've stripped off more insulation at one end of the wire than at the other. However, you can't have too long a wire for the female connector because that will interfere with the mating zone of the female connector, whereas you don't have to worry so much for the male connector, as I think you'll see. Next, remove a male connector from the set of DuPont male connectors by cutting one off. I just use my wire cutters to do that. You might want to trim off any sharp points that are left over where the connector has been cut off. The connector features two distinct crimping points. The first one being the conductor crimping area designed for crimping the bare wire, and the second one being the insulation crimping area dedicated to crimping the insulation. Understanding and utilizing these specific crimping zones ensures a secure and reliable connection. To assess the bare wire length, carefully insert it into the DuPont connector with the insulation arriving at the beginning of the conductor crimping area. You need to confirm that the bare wire is long enough to extend to the conductor crimping area of the male connector. If the wire appears too long, use wire cutters to trim it to the optimal length. Bringing the insulation up to the insulation crimping area enables a secure connection. This ensures a proper fit and functionality in the crimping process, and it enhances the overall integrity of the connection. You can either insert the wire into the connector first and then crimp, which is how I'm doing it in this demonstration, or you can hold the connector with the crimping tool first and then insert the wire into the connector. You need to hold the open end of the conductor crimping area of the connector into the die of the crimping tool. I'm using a 1.4 die size. Once in position, close the crimping tool to crimp the wire in place. Here is a graphic representation of the crimping action at the conductor crimping area of the connector. Next, we want to crimp the insulation crimping area of the connector. The crimp tabs might be splaying out too much, so it can be a good idea to close them first. I used a pair of pliers, but you can also use the end portion of the crimping tool to achieve the same result. Since the conductor crimping area of the connector is already crimped onto the bare wire, it is a lot easier now to position the insulation crimping area, or tabs, into the wire insulation die. The wire insulation die has a round shape this time, which matches the periphery of the insulation of the wire. Shape the insulation crimping tabs of the connector into a rounded form by closing the crimping tool. Here is a graphic representation of the crimping action at the insulation crimping area of the connector. Now check the connection, and if everything looks good, proceed to attach the connector to the housing. Align the pin of the male connector with the hole of the housing and push it in until it clicks. That completes the process. Now let's create a female connector at the other end of the jumper wire. Likewise with the male connector, remove a female connector from the set of DuPont female connectors by cutting one off. The female connector likewise has two crimping points, one for the bare wire and the other for the insulation, just like the male connector. You also need to be careful that the bare wire isn't too long, otherwise it might intrude into the mating zone of the female connector where the male header pin will be inserted. Use the crimping tool to hold the conductor crimping area of the female connector in place, like this. I'm using a 1.4 die size once again. Once in position, close the crimping tool to crimp the wire in place. Here is the graphic representation of the crimping action again at the conductor crimping area of the connector. And there is the conductor crimping area fully crimped. Next we want to crimp the insulation crimping area of the connector. The crimp tabs are again splaying out too much, so let's close them in a bit first. Now insert the insulation crimping area of the connector into the round die of the crimping tool and close the tool. Here's the graphic representation of the crimping action at the insulation crimping area again. Check the connection, and if everything looks good, proceed to insert the connector into the housing and push it in until it clicks. Double check by gently pulling it to ensure a secure fit. I did the same with the green jumper wire and inserted the female end into the same 2-pin housing to produce 2 jumper wires that share the same housing at the female connector end and have separate housings at each male connector end. You can use the same method to create all types of DuPont connectors for jumper wires. Here's a set of jumper wires with 4-pin female connectors at each end. So with jumper wires having DuPont connectors, now you can easily connect a circuit to a device like I'm doing here. This is part of my DIY autonomous mobile robot project. Click here to find out more.